Okay, जी guys, am I audible? Hello guys, am I audible? Okay, that's good. So, Mama, does that make sense? Your last question, Mama, does that make sense? Okay, that's good. ठीक है जी. So now let's basically understand deeper about the poles here, right? So now I'm gonna basically start the construction of a magnet, okay, how it's constructed over here, and we have answered this briefly in your first slides. Okay, I'm gonna dive deeper now over here, right? So I'm gonna announce in the group. Okay, everyone should be here. Let me, yeah. So yeah, let me just write a text here. So now, this is just explaining about the poles, which are basically the construction of a magnet here. Okay. Let me just announce. Rejoin. So a magnet is basically you can just draw a rectangle here, right? So it has obviously two poles here. So it has a north and a south pole, right? So a magnet has two poles, a north pole and a south pole, right? If a magnet is supported so that it swings horizontally in a plane, it comes to rest with one pole. The north pole is always pointing to, roughly towards the Earth's north pole here, right? Therefore, a magnet can be used as a compass here, right? So what are they saying over here? Let's say if you have a string, okay, and you have a wall here, okay. This is the wall here, okay. And let's say if you allow, let's say if we are holding the magnet by a string here, okay, it is a string here. And if you allow this particular magnet to swing freely, so let's say roughly the north pole of Earth is here, okay. So this would basically align towards this particular north pole of Earth here. So that is what is the purpose of a compass, right? So that is how compass is designed to operate here. Okay. So now some laws of magnetic poles. Okay, what are the configuration in which they would attract and what are the configuration in which they would repel, right? As you guys all shared over here, and that was good to hear. So let me just do the example here. So case one, okay, if we have two magnets here, this is a north pole, this is a south pole here, and if I try to bring in another magnet here, okay, a north pole here and a south pole here. So if you're holding it with your hands, you will basically feel a force in your hands that is going to basically be in this particular direction. Okay. So if you bring in two like poles together, so this will basically lead towards repulsion, right? This is basically case here. Now let's discuss case two here. Let's say now you have two magnets which are as follows. You have a south pole here, you have a north pole here, you have a south pole here, and then you have a north pole here, right? So now the force which you experience on your hand is going to be this, right? So if you have unlike poles which are pointing towards each other, facing towards each other, so this scenario is going to basically lead towards attraction here. Okay, so there are only two cases possible here in the case of magnets here. Okay, that is what I explained over here. If you bring a north pole towards the north pole of another magnet, they would basically repel. If you have two south poles towards each other, again they would repel, right? By contrast, if you have any basically alternate poles, let's say north south facing towards each other, south north facing towards each other, they would basically lead towards attraction. Okay. So what is the summary of the working principles of a magnet? That like poles would repel and unlike poles basically attract here, right? So this is a very important summary over here, which is asked in your MCQs and your theory, right? So again, the force of repulsion or attraction decreases as you basically separate them apart over here, right? Let's say if we have two magnets which are like this is a north pole here, this is a north pole here, and then you have another magnet over here which is basically a north pole here and a south pole here. They would be repelling, okay, but by a very small force here, right? But this force becomes prominent when they become basically in case A. Okay, so we will learn how does basically magnetic fields lead towards this. Okay, so if this thing makes sense, give me a thumbs up. If this point is clear, okay, it's clear to Umama, Varda, Meef, Mashal. Okay, what about Hamza? I hope it's clear to Hamza also. That's good, right? So we have learned basically the principle of magnets, how the construction of magnets, the law governing basically magnets. Okay, what are the laws which basically lead towards attraction or repulsion? Now, the question which basically Mama asked is, how does iron filling basically becomes magnetized? Okay, I believe that was the question. So that is called induced magnetism here, right? So what does induced magnetism means? It means basically transferring or magnetizing a material without physical contact. Okay, so this is basically the meaning of this particular term over here, right? So this is the beauty of magnetism here, that you can basically magnetize any material without any physical touch, right? So that is called induced magnetism here, right? So let me just explain the example and then we will see the example in detail. So when a piece of unmagnetized magnetic material, okay, touches, or let's say if you brought near to uh the poles of a permanent magnet, okay, so it becomes a magnet itself, okay. So the material is basically said to have magnetism induced in it. Induced means के without physical touch, ठीक है, you can magnetize it also, ठीक है. So what is happening here, let me just say show you in the diagram, ठीक है. Let's say this was a ferromagnetic material over here, right? It was a ferromagnetic material which we talked about in the start, which can be magnetized easily, right? And इसका example हम ले लेते हैं, let's say it is T, ठीक है. And let's say this is permanent magnet जो already आपको let's say you bought this from the market here, right? So initially this particular material was this, ठीक है, it had no poles, ठीक है. So when you brought this closer to this magnet over here, ठीक है, so what would happen, let's see. So you can see that it has induced a south pole here and a north pole here, right? So the induction takes place in this way, ठीक है. If you bring in any basically unmagnetized material which has no poles induced on it, so what would happen, so the internal structure of this particular material would arrange itself in such a way that it should basically lead towards attraction between these two, right? So obviously you know the rules that unlike poles should attract each other. Therefore if you have a north pole on the material which is basically inducing magnetism on the other, it would induce a south pole towards the north pole of itself, okay. And since it has south pole here, the other side automatically becomes a north pole here, right? So this basically induces without any physical touch magnetic poles on the ferromagnetic material which is steel over here. Now it is basically a sort of a magnetized material which can be used to attract or repel any other magnet also, okay. So that's how induced magnetism or basically works over here, okay. If it makes sense, give me a thumbs up. It makes sense to Mama and Mashal. Okay. Hamza also. ठीक है. That's good. ठीक है. So now we can basically check over here, right? We can check magnetic repulsion here. ठीक है. And how are basically atom fillings magnetized over here? See, so first of all, let's read the example. What is it showing over here? This can be checked by hanging two iron nails from north pole of a magnet. Their lower ends repel each other, right? And both are repelled further from each other when north pole of another magnet is closer together, right? So they are saying कि how is induced basically magnetism working over here, ठीक है, induced magnetism. So in this particular diagram A, so you have a iron nails which can be magnetized, right? So you can see that they are attracted towards the north pole here. Since they are attracted towards the north pole, they should have a south pole here and a south pole here, right? And automatically this side becomes a north pole and a north pole here, okay. So this diagram is showing that automatically these two north poles should repel each other, and they are basically have sort of a deviation between each other that is dictating or highlighting that these two RNAs are repelling each other over here, right? To just make it more permanent, you can bring in another north pole of another magnet, so you have more stronger repulsion between these two RNAs, and you can basically sort of visualize the effect of repulsion between dipoles here. So we had south here, north here. So now these would basically repel more stronger since we also have a north pole here, right? So does that make sense? Does this experiment make sense? If yes, thumbs up. It makes sense to Mashal, Varda, Hamza. That's good, right? That's good, right? So let's go on. So we have magnetization of iron and steel over here, right? So these are two types of material which we have, and we will learn get how does this magnetization works over here for these two type of materials, right? Uh Can anyone tell me कि मैंने आपको बताया था लेक्चर के अंदर कि one of them is iron or steel is basically ferromagnetic over here. So which one is ferromagnetic? Is it iron or steel? You just have to choose. You have
Sir,
the.
can you repeat the question?
I'm just saying कि out of iron and steel, which type of material is called ferromagnetic? Is steel ferromagnetic or is iron ferromagnetic?
Iron.
Okay. What does that say? Those who say iron is ferromagnetic, raise your hands. Okay. Mashal says it. Okay. Varda says it. Okay. So we have two people saying yes, sir, iron is ferromagnetic material here, right? So let's first of all read the content and let's come to the let's summarize it. Are we correct or not, right? So chains of small irons and steel paper clips can basically hung from a magnet over here, figure 4.1.3 over here, right? You can see that we have steel clips here, right? And we have iron nails here, right? So both of them basically we can stick them on one of the sides here. So if we basically stick iron on the north pole here, it will induce the south pole on the top of an iron nail and a north pole on the tail, right? And so on and so forth. It will repeat in alternate pattern so that it form a chain of iron fillings, right? So similarly, ठीक है, if we basically attach a steel clip over here, so on the south pole, so it will reduce the north pole here to form a traction, and the other side of the steel clip will be south pole, and it would repeat in alternate way to basically form a chain of steel clips over here, right? So now both of them can get magnetized over here, right? But the question is कि which one can basically retain, which can basically store magnetism for a long time, right? Right? So let's see that. So each nail or clip basically magnetizes the one below it, and unlike poles are formed to attract it, right? And you can see we have a chain of our basically consecutive opposite poles, which is causing attraction, and it basically causes a chain of iron is on the left and a chain of steel clip on the right over here, right? So when if the iron chain is removed by pulling the top rail, the chain collapses, ठीक है, showing the magnetism induced in iron is temporarily over here, right? So if I just break this path, ठीक है, so this chain will break down and basically spontaneous instantly over here, and this is reflecting that it cannot store, it cannot basically retain magnetism. However, if you basically do the same with the steel chain, it does not collapse, ठीक है, magnetism is induced in steel is permanent over here, right? So if I basically, let's say, break this path here, so this chain will automatically not break, it will remain intact over here. That means कि steel can retain, it can store magnetism itself, okay? So this steel is basically called, your steel is basically ferromagnetic material here, right? Because it can basically become magnetized easily, right? And it can also become a magnet, a permanent magnet over here. Okay, so quantity, a type of material which can basically become a magnet permanently is called a ferromagnetic material over here, right? Which property which we have learned in the start of the lecture over here, right? So it is called ferromagnetic material, right? And we also give it another name, that is temporary magnets and permanent magnets over here, right? So temporary magnets are made up of soft iron. Okay, they lose their magnetism easily. However, permanent magnets are made up of steel. They can retain their magnetism over here, right? So this is how you basically define the two types here. Okay. So if it makes sense, give me a thumbs up. Okay, it makes sense to Hamza. It makes sense to Mashal. It makes sense to. Okay. Okay, good. So Mama is here. Mama, you can watch the start of the lecture as a recording. Okay. So we're continuing the last chapter, right? Okay, so we have again gonna go into the type of magnetic materials over here. Okay, so material types, right? So materials such as iron, okay, they can magnetize easily, but they can lose their magnetism easily. Okay, they're said to be soft. Okay, So material those which can retain the magnetism after magnet is removed, they're called hard materials. Okay. So both types have their uses. Very hard ones are used to make permanent magnets here, right? So this is an example over here. K. You have now two types here. Okay, hard, soft, right? These are hard ones are also called permanent magnets. They're also called permanent magnets. And soft ones are also called temporary magnets, right? An example of the type of material which are called hard material are called steel. And the example of the material for soft material is basically iron, right? This is a summary of which we should know about the type of materials here, right? So now let's basically go on to the another type of content side here, that is magnetic and non-magnetic material, right? So you might have seen there might be some materials that can become magnetized. Let's say you have magnets, it can stick to the basically the refrigerator panels. Okay, it can stick to, let's say, your metal cupboard. Okay, but if you try to basically stick your magnet, okay, onto, let's say, wood, or let's say a plastic material, it won't stuck onto it, right? So that's how we basically have type of materials here that are magnetic and non-magnetic materials here, right? So you should know the types and the definitions, okay? So the first one is magnetic materials, okay? And the examples for them are they have iron, steel, nickel, cobalt. They can be attracted by a magnet is basically and can magnetize temporarily or permanently over here, right? So any material which can be attracted by a magnet, okay? And if you try to basically induce magnetism onto that, so if they can magnetize temporarily as basically temporary magnets or permanently, right? So either of them is basically, if any material fall into this category, that is called a magnetic material over here. Right? Then we have non-magnetic material, okay, which cannot attract or which cannot be attracted by another magnet over here, right? So we have aluminum and wood, right? They cannot be attracted by a magnet and they cannot be magnetized over here, right? So these are the two definitions which you should know. And it comes for only 1 marks, okay? So they come for 1 mark in your exams, okay? Or in the MCQs. So you should know this, okay? This is a summary or definition which should be basically learned by you guys over here. So magnetic material basically can be magnetized by a magnet, okay? So in the magnetized state, they are attracted by a magnet, okay? So we can basically, you can also relate this with the definition of basically ferromagnetic material, right? So if you recall the definition for ferromagnetic material, it's almost the same, right? Okay, so if you learn the definition for one, for the other one, you can just automatically basically copy it, right? And then you have non-magnetic material, which cannot be attracted by magnet, and if they are unmagnetized, okay, they cannot be magnetized also. Okay, so you cannot do anything with them. It's just used for isolation, right? Actually, if it is clear till now, give me a thumbs up because now I'm gonna start to learn how to plot field lines. Okay, it's clear to Maeve, Omama, Hamza, Mashal, Vardhan. That's good. Okay. Now we have learned the properties and the types of magnetic materials. How can we induce magnetism onto that? Okay. We have learned how do we plot poles on a magnet. Now we should know how do we basically plot a magnetic field line over here, right? How do we plot magnetic field lines of magnet? Okay. So for that, I'm going to basically go towards another blank slide. So you should know. So we are starting to learn plotting magnetic field lines. So for this, you should know first of all two rules. Okay. The rule A is that if you have a north pole, the magnetic field lines always go out of a north pole, right? Like this. Okay. The second rule is that If you have a south pole, the magnetic field lines always sink into the south pole. They go into the south pole, right? Now, let's plot a magnetic field line for a magnet. Okay. So let's plot magnetic field line, magnetic fields of a bar magnet. So you have a magnet here, right? Let me just choose this. Let me do into color. It's not converting into shape. Okay, let me just do it again. Ding, 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 ding. Okay, I will have to make it on my own. Okay, into shape is not working. So we have a magnet here. Okay, and it has a north pole here. Let me just draw the halfway point here. It has a south pole here, right? Now I want to draw the magnetic field lines over here. So what is rule A? Okay, it goes out of the north pole, and it basically rule B is what? It goes into the south pole here, right? So I'm gonna make the field lines like this. Okay, the first one should be like this, and then you should have the second one with an increasing space. Okay, with an increasing space like this. Okay, and the second one should be from the bottom. ठीक है, and you should have another one which should have increasing space here, right? So the distance between these two should be increasing, right? ठीक है, so that's how you plot the magnetic field lines. And then you want to plot more lines like this. ठीक है, you want to assume that because of lack of space you cannot plot it further away, but they are going out, right? And they are sinking in over here. So arrows are very important here. So on north pole you should have all arrows coming out. ठीक है, going out of the north pole, and all arrows coming into the south pole here, right? Into the south pole, into the south pole, into the south pole here, and into the south pole, right? So that's how you plot a magnetic field line of a magnet here, right? So if it makes sense, give me a thumbs up. Okay, how do you plot magnetic field lines? Okay, it's clear too. I hope everyone. Okay, so Vardha, clear? है? Okay, clear. So now important points over here is that okay. So the closer the field lines are, you can see the field lines are pretty closer. The field lines are pretty closer here, right? And their field lines are pretty closer here, right? Right. So this is very important point here. So the field lines are dictating the magnitude of force. Magnitude of force. So what do I mean by that? I mean that okay. So closer the field line, if you're, let's say another magnet is very, let's say closer to the south pole of this magnet here. So you can see the field lines are pretty closer over here. So the force magnitude will be huge over here, right? So if field lines are pretty closer together, okay. So if your field lines are closer. So you will have greater force of repulsion or attraction here, right? Either way, right? So if let's say your magnet, if you bring a magnet, let's say here, okay, another magnet here, there's a north pole here. But you can see that field lines are pretty far away from here. Okay, it has greater separation here. You would feel a force on another magnet, but it won't be of such huge force, right? So this is a summary here. Okay, field lines. If your field lines are up, basically, if you have a basically a magnet which are placed in a region where field lines are apart from each other, right? So you will have what? A weaker, a weaker force of attraction or repulsion, right? This is a summary of basically what you should know about by just seeing the field lines here, right? Okay, you would need to analyze this. Okay, you, there might be a question. Okay, let's say if the field lines are closer, what another magnet when brought together, okay, when brought closer to the first magnet, would experience a greater force or a weaker force. Okay, so you should be able to answer that by just seeing the distance of separation between the field lines here. Okay, so now this is a basically a method to detect a magnetic force here. Okay. So what is happening here? You have a cock here which is made up of wood. Okay. It lets this particular rod, the gray rod, to float. Okay. Okay. And we contain, you can basically it's a bowl of water over here, and it's a steel rod here, right? So what is happening here? So this is the line of force जो हमने basically magnetic field line बनाई है, right? It goes from north to south, right? It makes sense. ठीक है? And you would have multiple field here also, ठीक है? At the top, like this, north to south, ठीक है? It will go like this, north to south, ठीक है? And so on and so forth, right? So now you can see that since this particular field line is going from north to the south here, ठीक है? So what is happening here? This particular steel cock basically has induced a north pole here, and this has they basically induced a steel rod. So this steel rod has basically induced the south pole here, right? So this is basically also one way of detecting a magnetic field force here, right? अच्छा, अब now imagine कि now this is already magnetized here, ठीक है? This steel rod is already magnetized. So now you can see कि north and north should repel. So depending upon the field line, this would basically start to move in a particular direction here, right? So this would basically highlight कि you are basically within the magnetic field lines of a planet, and this force is going to basically detect कि हमारे पास कौन सी force लग रही है, is it repulsion or is it attraction over here? ठीक है? Does that make sense? If it makes sense, give me a thumbs up. Just experiment just to see if there is a force or repulsion or not. Right? Okay, it makes sense to me. It makes sense to Hamza. It makes sense to okay, Varda. Yes, Mama. What is not clear?
So there's a bit of a confusion on detecting magnet.
Mm-hmm.
I am
So let me
confused
just
in that
first
part.
summarize this content here from which we missed. The space surrounding a magnet where it produces a magnetic force is called a magnetic field. ठीक है? The force on around a bar panel can be detected and shown to vary in direction using a precision basically 4.14. ठीक है? अब जो हमारा experiment था, which is this 4.14, is basically used to detect the strength of magnetic field over it, right? तो हम जितना क्लोज होंगे नॉर्थ पोल ऑफ मैग्नेट के, ठीक है, फ्रॉम इफ वी आर बेसिकली क्लोजर हियर, सो द फोर्स ऑफ रिपल्शन विल बी ग्रेटर, राइट? बिकॉज डिस्टेंस इज प्रीटी क्लोज एंड यहाँ पे हमारे पास फील्ड लाइंस बहुत ज्यादा हैं, ठीक है? एंड इफ यू बेसिकली गो इनटू दिस रीजन, लेट्स से इफ यू basically wooden cork is here, you have very weaker sort of field lines here, ठीक है? So now what is basically in this apparatus happening here is as follows, ठीक है? If the floating if the floating magnet is released near the north pole of the bar magnet, it is repelled to the south pole and moves along a curved path, basically, which is called the field line here. It moves in the opposite direction if its south pole is the uppermost here. ठीक है? So ये हो क्या रहा है यहाँ पे? So you can see this, ठीक है? As I told you, okay, this is the field line of the bar magnet here, ठीक है? And this basically मैग्नेटाइज मटेरियल जो हमने कर दिया है स्टील को टेम्परेरीली, ठीक है? So this would follow this trajectory of the field line, ठीक है? So this would basically generate कि आपके पास pattern of the field line is basically this. So this particular steel bar would complete a round like this in the water, right? And this round can be mapped as a magnetic field line over here, right? If we had south pole here and a north pole here, ठीक है? And if it was placed here, the cock, it would move in this direction, ठीक है? So the magnetic field line would be same, but the direction would be opposite over here, right? So now does it make sense? मैमा,
Yes, sir.
ठीक है. Just the experiment to just to basically have experimental way to create basically sketch a field line here, right? Okay, so magnetic fields, just a summary of this जो हमने अभी डिस्कस करा है. So it is useful to consider that a magnetic field has a direction, ठीक है, and to represent the field by line of force, ठीक है. So it has been decided that direction of magnetic field lines at a point should be the direction of the force on the north pole here, right? To show the direction, arrows are put on the lines of force 10 point away from the north pole towards south pole here, right? So they're just saying कि हमारे पास if we have a magnet, ठीक है, we basically use arrows to represent the magnetic field line and it goes from north to the south pole here, right? So we assume that if any magnet of any material is basically close enough to this particular field line, like this in the experiment, so this would basically cause a force on this particular steel bar to basically move along this trajectory over here, right? So this is basically the way we plot magnetic fields here. It goes from north towards the south pole over here, right? ठीक है. And the starting point of the arrow of the vector is basically pointing towards the north pole of the magnet over here, right? ठीक है. So this is the rule, this is the way we basically draw magnetic field lines here. The direction of a magnetic field at a point, ठीक है, direction of the force on the north pole of a magnet at the point over here, right? ठीक है. So just saying कि हमारे पास जो डायरेक्शन है हमारे पास the field का which we sketch over here, it goes from north to south. So the starting point of the field is basically the north pole of a magnet, right? And the force is basically directed towards what? Is directed towards in this particular direction here. Does that make sense? If yes, thumbs up. It's simple, right? We have done this already multiple times. This makes sense to Vardar, makes sense to Mama. Okay, makes sense to Maeve, Mashal. ठीक है. Just a summary of what we have discussed now multiple times. ठीक है. So the field lines is basically drawn using this. And strength of magnetic field हम कैसे check करते हैं? So magnetic field is stronger in regions where the field lines are closer together. ठीक है. And then when they are further apart over here, right? And assume basically, as I explained over here, the region can basically shade regions here. Like let's say this yellow region, okay, this yellow region here, and let me shade another region, this blue region here, and then this blue region here, right? So if I basically want to color code this, so this is the blue region I'm talking about, and this is the yellow region I'm talking about over here, right? Yellow one are the region where basically field lines are pretty closer together. So if we place any magnetic material or any, let's say material which can be magnetized, would experience a huge force, okay, near this near this particular yellow regions over here. However, in the blue regions, it would experience a force, but not of such intense magnitude over here, right? I hope it makes sense, right? Okay, good. So yeah, I can see Mama playing on the screen. Okay, Mama. Acha ji, then we have electromagnets here, right? So now we can see that we are combining electricity and magnetism together over here, right? What is electromagnet here? So this is basically, imagine this, that you have a coil, right? And if you pass current, let's say if you basically put a supply of, let's say, some voltage here, this particular section of coil becomes magnetized, right? It becomes, let's say, north pole here and south pole here, right? So this is basically a way of using electricity to produce temporary magnetism onto a coil, and which can be used as a magnet over here, right? So we have combined now electricity and magnetism together over here. Okay, that is the beauty of physics, right? You can cross combine the fields over here, right? So let's see okay, what is an electromagnet over here. So an electromagnet is formed from a coil of wire through which electric current flows, okay, and which can basically allow the strength of a magnet to be varied here, right? Let's say if you make the voltage supply to be, let's say, 10 volt here, then you increase the supply to, let's say, 100 volts. So obviously that would increase the current also, and that can basically control the amount of basically strength of the magnet. Okay. So the magnetism of the electromagnet is temporary. Okay, can be switched on and off. Okay, that is the benefit of this. ठीक है, and it has a soft core iron which is magnetized only when there is a current in the surrounding coil here, right? So obviously in the center we have a soft iron core to basically maximize the effect of the magnet over here, right? So we have a summary here. Okay, the strength of the electromagnet depends upon three things here: the amount of current flowing in the coil over here, the number of turns of the coil, and the poles are moved closer together over here, right? Let's say if I have this scenario, I have this scenario over here, right? Let me just draw the case here. I have a iron basically, let's say this is iron, and this is my wires coil here, right? My coil is going around this, right? And this is my battery here. Okay. So you can see that it has n number of turns, ठीक है, and it has basically a current going in towards the coil here, ठीक है, and basically then we have basically the spacing between the north and the south pole here, ठीक है. Okay, how what is the size of this? ठीक है, the diameter distance d over here. Okay, let's say if the current is entering here, so this would be the north pole here, right? And this would be the basically south pole here, right? So if you want to increase the strength of the electromagnet, if you want to make it more stronger, so you can do three of the things. You can increase the current, okay? So if you increase the current in the coil, the basically magnetism induced will be very strong, and that will basically create a very strong temporary electromagnet. And then if you or basically if you increase the number of turns, that is n here, okay? So that will also basically increase the strength of the magnet, and if you basically cause the poles to move closer together, if you reduce this distance d, so that would also basically cause the electromagnet to be very strong over here. So now you know okay, what is it, right? So you might have also recalled कि हाँ मैंने इसको यहाँ पे देखा था in certain movie or vlog or let's say some reel. So I want someone to basically give me an example कि where is it used in real life. These are widely used by the way, ठीक है, and they're very useful. You might have watched this in a movie also, a comedy movie also, ठीक है, where they used electromagnet to basically play around. Can you give me an example? कि where do we find these electromagnets? कि जब भी हम current को let's say electricity supply on करें, they start to basically act like magnets, and when we basically stop the electricity flow, they basically becomes demagnetized. Has anyone seen this before in the live movie? What about this? Those who have basically seen this in movies or let's say real life, give me a thumbs up. Mashal has seen this. Maeve has seen this. Mama, Varda. ठीक है. So I believe everyone has seen this, right? So what is happening over here? So they have a crane here, ठीक है, and this is your electromagnet here, right? This is your electromagnet here, ठीक है, and this is a scrap metal material. Let's say इसके अंदर this is a garbage here. It has steel plus plastic plus let's say clothes, ठीक है. So if you want to basically sort out the material, if you want to basically only remove steel from the garbage, so you can use basically electromagnet here. So as soon as the current passes through this, it becomes a magnet, and only let's say steel is basically carried and attracted towards, they're stuck to this particular electromagnet, and they can basically easily sort out this particular garbage here, scrap material over here, right? I hope it makes sense now. Okay, so this is the diagram over here which I was saying pehle se. So this is the plus supply over here. This is the negative supply here. Okay, and current is going in this direction here. It's coming out from here. Okay, so this is a soft iron core. This is a soft iron core which can be used here. Okay, and this particular side is the north pole here. So the side where the current enters is basically called the north pole here. You can see the north pole is here, and the side where the current exits is usually the south pole here, right? So, and again, if you want to draw the magnetic field lines, they will go from north to south, okay? North to south, 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 right? And you can have multiple shapes of this iron core over here, okay? Can be also just a rectangular cube also, okay? It can be, this is sort of a horseshoe, okay? If you see a horse, but basically shoe, it's in the shape of this over here, right? So yeah, this is just example over here. This says just saying कि हमारे पास the core is letting the current to flow in opposite directions. It goes from here till here, right? So this basically current entering side is known as the North Pole and the current exiting side is called the South Pole here. And that's how we basically have just used current to produce magnetism in a soft iron core. And if you recall that iron is a temporary magnetic material over here, right? Iron is basically a temporary magnetic material here, right? So you cannot regain its magnetism over here, right? Some might say कि सर ये तो already magnet है iron, तो ये खुद ही iron basically iron is making its poles automatically here. It's not, it's temporary, right? If you remove the current, it will basically lose its magnetism. Okay. And again, these are the uses over here, which you basically want to go through, which is very simple. So permanent magnets are basically made from magnetic materials such as steel. Okay. They can regain their magnetism, which we have learned multiple times, right? So they can be used in applications where magnetic field does not need to be valid. Okay. So if you want the magnetic field to be fixed, okay, वो vary ना करे, so you can use it over there, right? Like generators. Okay. Uh, then this includes compass, computer disk, electric motor, ठीक है, electrical generator over here, microphones, loudspeaker, ठीक है, debit card, credit cards, ठीक है. So if you know learn any three of them, that is more than enough, ठीक है. So now, what is the advantage of electromagnet? ठीक है, that we can control it, ठीक है, we can turn it on and off instantly almost, ठीक है. So it can basically so the advantage of electromagnetic is basically that it can be controlled. Okay. But what is the disadvantage over here? It cannot regain magnetism for the entirety. Okay, for long enough time. So over there we can basically use uh this particular type of material, which is basically called permanent magnets over here, right? So they are used temporarily. Okay, and they are used basically when one wants to basically vary the strength of the field. Okay, and they can be using cranes to lift iron objects, scrape iron, so on and so forth over here. And this basically marks the end of the chapter. So I believe it is